Hey everybody. Sorry I'm not with you today, but today we're going to do some SQL review, and the first thing we're going to talk about is this thing here, cube roots. We didn't do cube roots this year, but we did do square roots or radicals, and it's very similar to that. So let's get to an example. Back when we did radicals, we had like the square root of 80, all right? And the square root of 80, remember we did this factor tree? We had 80, and we broke it down. What times what gives me 80? Well, I see it ends in 0, so I could break it down by 8 and 10. 8 times 10 gives me 80. 10 I can break down more. I can get 2 and I can get 5. 2 and 5 I can't break down anymore, so I'm done there. But 8 I can break down more. I can break down 8 into 2 and 4, right? And then 4 I can break down more into 2 and 2, right? So then remember we rewrote it, all those numbers underneath the radical sign. We had 1, 2, 1, 2, 3, 4 2's. 1, 2, 3, 4, and then we have 1, 5. So write all those prime numbers underneath the radical, right? Do you remember that? And then we said, all right, what pairs do we have? Remember we looked for pairs, and we had a pair of 2's, and we have another pair of 2's. So both of these can come out from under the radical, right? And whatever didn't have a pair had to stay in the radical. So I pulled out a 2, and I can pull out another 2, and then that 5 is trapped inside. And then I can multiply the 2 that I pulled out, and 2 times 2 gives me 4. So this would give me 4 square root 5. All right, so that's what we did when we did radicals, right? When we did square roots, simplifying square roots. So cube roots is kind of the same. So if I was going to do this one, the cube root of 250, well, I would write that down, and I would say, all right, what times what would give me 250? Well, ends in 0. Whenever it ends in 0, you can always say 10. 25 times 10 will give me 250. 25 I can break down more, because 5 times 5 gives me 25. 5s I can't break down anymore, those are prime. 10 I can break down, though, into 5 times 2. Right? So now I can rewrite my prime numbers underneath my cube root this time. So I have 3 5's, 1, 2, 3, and I have 1, 2. All right, so the difference between a radical and a cube root is cube root, you want to look for groups of 3. So think about like square root, you want to find twins. Cube root, you want to find triplets. So I want to look for groups of 3 or triplets. And I see I have one group of 3. I have all these 5's a group of 3. I have one group of 3 of 5's. Right? So that means those 5's can get pulled out. So that means that 5 would get pulled out, and then I would still have cube root, and whatever didn't have a triplet or didn't have a group of 3 stays under. So that 2 would stay under. All right, so that is how we simplify cube roots. Very similar to what we do with square roots, but square roots we're finding groups of 2, cube roots we're finding groups of 3. And the way you remember that is there's a 3 right there for that cube root. So you just do the factor tree, find your group of 3. Whatever has a group of 3 gets pulled out from underneath the radical. All right, one more. All right, so this one has a 3 on the outside and 108 on the inside. So 108 I have to break down, and this is a cube root, so I'm going to be looking for groups of 3. 108, what times what will give me 108? Well, it's even, so I know I can do 54 times 2. 54 times 2 would give me 108. 2 I can't break down anymore, but 54 I can break down. 54 would be 6 times 9. 6 times 9. 6 we can break down into 2 times 3. And 9 we can break down into 3 times 3. Now I'm left with all prime numbers, right? So I'm going to rewrite my radical. So I have a 3 here. I'm rewriting that. And then I have cube root. And I'm left with 1, 2, 3 3's. 1, 2, 3. And there's a multiplying between each. And I'm left with 2 2's. 2, 2. All right, and remember, I'm looking for groups of 3 because this is cube root. Cube root, I'm looking for groups of 3. I see a group of 3 3's. So that means those can get pulled out. So that means on my outside now, I have this original 3 and the 3 that I pulled out. And what's left on the inside are these 2's because there's only a pair. It's not a group of 3. So those are going to stay on the inside. So they have my cube root, and I'm still stuck with that 2 times 2 here. All right, so now I can simplify. So now I can times these two here. 3 times 3 gives me 9. And then I have cube root, and then 2 times 2 gives me 4. And there's my answer, 9 cube root 4. All right, on this one over here on the right, this is kind of like working backwards. All right, so this is like the answer, like this thing here that we just got, and they want to know what the original one is. So basically what we're going to do is the opposite of what we did here, right? So if this 5 got pulled out, that means to go back in, it would have to have a group of 3, because it's a cube root. So that means that this would really be, that 7 would still be there, but to move that 5 back into the radical, that means that there's actually 3 5s underneath the radical. So then I can multiply all these together to get my original cube root. So I would do 7 times 5 times 5 times 5. So let's see here, 5 times 5 is 25. 25 times 5 is 125. 125 times 7 gives me 875. 875. And that is my final answer. All right, so when you're dealing with cube roots, you're looking for groups of 3 or triplets that you can pull out. When it was square roots or just regular radicals, you were looking for pairs or groups of 2. That's the main difference. And the way you can tell and memorize that is if you see a 3 there, you're looking for groups of 3. All right, hope you got that. Hope you do well on your practice.